Hello and welcome to our part 2 of describing common network application attacks. Web-based attacks often take advantage of both social media sites and applications written with the Web 2.0 specification, both of which are either susceptible, vulnerable to human behaviors, or even the back-end infrastructure such as WordPress that was used to create the website. Exploit kits such as Angler can be used to take advantage of these known vulnerabilities. So truly the best approach to these such attacks is going to be education of our end users and how to conduct themselves on the web, on these social media sites, and especially what suspicious activity to look for. So an example of a web-based attack might be a user going to a website that has maybe banner ads or multiple different types of Flash content, and there being a Flash exploit. The Flash exploit could then be used to copy the previously uploaded CryptoWall binary, and we talk about CryptoWall in another part of these recordings. Once that binary is downloaded and now infects the client here on the left, that client can then be used to signal the command and control server that may update the code of the exploit, might then send instructions. And this instruction here in step 5 could be to encrypt the infected client's documents. Then, of course, once the encryption is done, signal the command and control server once again to provide the ransomware note, maybe a pop-up or an email, to instruct the user that your systems have been compromised and your data has been encrypted, and contact us to pay for the decryption key. HTTP 302 cushioning requires a few definitions before we go deeper into this example. For example, all HTTP communication has a series of verbs or commands sent to the server and responses or status codes coming back from the server. So for example, a 302 found is a common HTTP response status code. In this case, it can actually be used to perform what is referred to as URL redirection. Now, the cushioning part comes into case where we talk about iframes or inline frames, the ability, a standard programming mechanism of displaying a web page inside of a web page. So a compromised server could be used to display multiple different web pages inside of a request response interaction, all to redirect the end user to a malicious website. So of course, some of the different ways we can combat this obfuscation or this hiding in plain sight of the ultimate destination, the compromised web server destination, is by, of course, educating our end users, using something like Cisco's Web Security Appliance or WSA, and then also, again, Cisco's umbrella. So if we take a look at our example here, where we're showing some interaction where Wireshark was used to capture the HTTP request response, we can literally see the 302 status code with a phrase temporarily moved, and then the new destination to which the victim's system has been redirected. All once again with an HTTP 302 cushioning style of an attack. Command injections, as its name infers, is a process of injecting or executing code, executing commands, often arbitrary commands, on web servers with a vulnerable web-based application. Some specific examples that we're going to go over in the next few moments is going to be SQL injection and XSS, also known as cross-site scripting, or sometimes even abbreviated as CSS. And the idea here is normally the vulnerable web-based application does little to no user validation and code validation of what's being uploaded to forms that are expecting input. So again, no input validation whatsoever. To make it even more exciting, and yes, that's sarcasm, the attacker will hide in plain sight or obfuscate the string, the text that they are injecting using what is referred to as Unicode, or a universal code, a universal character representation, irrespective, that's where the word universal comes from, irrespective of operating system, region, or language. So some of our countermeasures, as we mentioned a moment ago, if one of the vulnerabilities is zero to no user validation or input validation, well, one of the countermeasures is to start validating your input. Start validating the source of the input to mitigate these types of injections. And then also, because of identifying Unicode, identifying the protocols, the styles of injections are common countermeasures as well. Deploying an IPS sensor or an IPS solution would really help in the process. Finishing our review of common network-based attacks with email-based attacks. My goodness, depending upon how long you've been around in the industry, email-based attacks have been around forever, whether it be spam messages or getting an attachment that just seems a little bit weird, seems a little bit out of place, knowing not to double-click and therefore execute that attachment. Spoofing emails where you claim or the email claims to be from a source or for a subject, but we all absolutely know it is not for that particular subject, or even mail servers that have not been hardened, not been properly configured, and now are acting as, or maybe even compromised and used as open mail relay, all the way up here with finishing up with our homoglyphs, where homo being same and glyphs being characters. Literally, if you look closer at a URL where, for example, as we discussed a moment ago, the Unicode character might look a lot like, but absolutely not be the same as the actual ASCII character. So to the untrained eye or a casual look, you see the characters that all look the same, and the untrained user clicks on the URL, but unbeknownst to them, they clicked on a URL that is going to a malicious destination. So some countermeasures that we've talked about before, of course, is going to be educating the user. No, don't click on that attachment unless you know that person is sending you the attachment. No matter how enticing the spam mail might be, don't open it up. And then also going a little bit further still, of course, hardening your systems using web proxies, and then additionally products from Cisco like the email security appliance.